Hello. The topic that we are going to discuss is about dynamic routing. So dynamic routing is a kind of routing protocol. So in this topic we are going to discuss three main topics. The first one is about dynamic routing protocol. The second one is about the types of dynamic routing protocol. The first one is called the distance vector. And the second one is called the link state. So we're going to discuss these topics in the future. So whenever we think of dynamic routing, we need to consider these issues. The first one is whenever you have a larger network. So if you have a larger network, usually for this kind of larger networks, we usually recommend what kind of routing protocol? Dynamic routing protocol. Why? Because in the case of very large networks, it's very difficult to configure static routing. You do know that static routing is whenever you configure a routing so that you want to reach from the source to the destination. But in the case of dynamic routing, you are the one who's going to, the network by itself or the configuration by itself will select a path which is optimal by itself. For example, let us assume that we are going to take this route in the case of static routing. So usually static routing will follow the same path again and again most of the time. So if something happens, for example, if this cable is damaged, the static routing will not select an alternative path. But in the case of dynamic routing, you have so many redundant paths. So you can use one of these redundant paths. For example, you can take this path from here to reach the destination. You can select this path. So we have multiple options. So if something happens, you can select the path which is optimal. So another one is it will automatically implement. Automatically means if something happens to the network, it will select an alternate path. So in the case of static routing, there is no alternate path. You have only some specific paths that you are going to take. And if something happens to those paths, you just will be stuck at some point. So in the case of dynamic routing, we have many alternative paths. So you can see to reach from, let us say this is the source and this is the destination, we have multiple paths. You have multiple paths to take from the source to destination. So you won't be, you'll have many alternatives. So let us subdivide the dynamic routing into two portions. So dynamic routing is subdivided into two parts. Usually we are going to cover these two topics, the distance vector and link state routing protocols. But in general, dynamic routing protocols are subdivided into an interior gateway protocol and an exterior gateway protocol. So interior gateway protocols are usually which are conducted in the same service provider network. So let us say this is our telecommunication. So telecommunication will use an interior gateway routing protocol. So if you take Ethiopian telecommunication, Ethiotel, so in this case, that's what we call it, an interior gateway routing protocol. Usually, it is connected by the same routing protocol principles and inside. So if it is an exterior gateway protocol, so you have two different, let us say internet service providers, ISPs. So this is ISP1, this is ISP2, internet service provider 2. So usually they will be connected using the exterior gateway protocol. So this is the exterior gateway protocol. But this one is an interior gateway protocol, and this one is also an interior gateway protocol. So whenever you connect two different interior gateway protocols, we use the exterior gateway protocol. One of the examples of exterior gateway protocol is border gateway routing protocol. So in general, we are going to discuss two topics. So we said we are going to select EIGRP from the distance vector, and we are going to select OSPF from the link state routing protocols. So what is the purpose of routing protocols? So the purpose of routing protocol is what? The first one is discovery of remote networks. So you need to know what the remote networks are. So we'll come up, we'll discuss about what is the remote network. So we'll say another one is you need to have an up-to-date routing information. So if something happens to your network, always the router need to have an updated routing information. Why? Because if something happens, you're going to select an alternate path. That alternate path should be safe and sound. So another one is you need to select the best. Not only an alternate path, you need also to select the best path. So the best path, alternate path is one option. Among the alternate paths, you need to select the best one. So these are, if something happens again, if the best path, if something failure happens to the best path, you need to select the new best. So these are the different concepts which are related to. So you can see here there are so many types of what. So you can see here this one is what? An interior gateway routing protocol, another interior gateway routing protocol, another interior gateway routing protocol, another interior gateway routing protocol. And in this case, we might sometimes use what? Static routing and default route. We will discuss those topics. So between an interior gateway, this is an interior gateway protocol, another interior gateway protocol, we will use what kind of protocol? The border gateway protocol. So what is the distance vector means? So distance vector means, as the name suggests, it has a distance and it has also a vector. So when we say distance, it means what? It means how far it is to reach the destination. So based on what calculation do we select? We say how far. How far depends on the number of hops, on the number of cost, on the bandwidth, on the delay. These are the criteria to know how far your destination is. So for example, you can see to reach from router 1 to router 2, you don't have any hops. So hops means the number of routers in between the source and the destination. If there is one router between these two, we say there is one hop. We're going to. Another one is we need to specify the direction. So either you can specify the next hop router or the exit interface. So the next hop router, it can be an IP address or it can be an interface. So for example, here you can see an exit interface is this one, exit interface. So this is going to be serial 0/0/0. This is an exit interface. The next hop router means the IP of the next router. So distance vector routing protocols, there are the different types of distance vector routing protocols. The RIP version 1, the RIP version 2, the EIGRP of the Cisco proprietary, and also the EIGRP. So the only two things that we are going to consider it, EIGRP 2 and RIP version 2 and EIGRP, which is the enhanced form of EIGRP. So when it is obsolete, means it's no longer existing. Legacy means that also it's not being that much used. So we said what? Distance vector will have what? Two criteria. What are those two criteria? The distance and the vector. So distance and vector are crucial points. So distance vector routing protocols, they consider how far we are, that is the distance, and in which direction. So that's we call it that's what we call it vector. So in this case you can see that there is one hop. One hop means almost only one distance. So for example, if you want to reach this network, you see that this network 170 something, to reach this network you need to pass from here through this router. So that's one hop. That's what we call it, one hop. That means what? In order to reach from router 1 to this network, you need to pass router 2. So router 2 is one hop. If you have 2, then we are going to select another one. So what about the link state? Link state uses, the name by itself is explanatory, because it says the state of the link. That's what we call it, the link state. So the link state router uses what? Routing information to create a topology. It will create a topology. Then it will select the best among the topology to reach the destination. But one of the advantages of the link state routing protocol is they don't use what? Periodic update. So periodic update means what? They don't send routing protocol information every either 30 seconds or every 1 minute. There is no periodic or being repeated at the same time. Just only the update only whenever there is a change in the topology. Only if there is change in the topology. For example, you can see here this the red X indicate that the link the path to that direction is damaged. So now what? This kind of change need to be distributed to everybody. That means to router 2, to router 4, to router 3, so that whenever they want to send something to this direction, they won't send it now. Because why? Because this kind of information should be updated by everyone. So you can see that router 3 is getting a message from router 1. What is that message? It is router 1 is sending a message to R3 by saying that what? The network to the left of me is damaged. So don't send any kind of information to those networks. So there are types of routing protocols. Some of them we call them classful. When we say classful, you do know that there are different types of classes. So you have the from 0, 1 up to 127, it is class A. So if it is class A, what? Class A. So what is the class A subnet mask? That is 255.0.0.0. So this is the subnet mask. So you cannot use this kind of subnet mask because it is class full. So if it is class full, the subnet mask is already pre-configured. You cannot change it. So if it is classless, we are expected to provide the subnet mask. We are the one who is going to provide the subnet mask. The system does not provide the subnet mask by itself. But if it is classful, we don't provide the subnet mask. The system by itself provide what kind of information? The subnet mask. So the classful routing protocols, they cannot support this kind of the variable length subnet masking, and the classless in the interdomain routing is not supported by the classful routing protocols. If it is classless, we are the one who is going to provide the subnet mask. Just remember that. Whenever you provide a network, you will provide the subnet. So from this, for example, you can see here, this is what kind of routing protocol? The variable length subnet masking. Here you can see it is /24, here it is 30, here it is 24. So it means that it's variable length subnet masking. It's not, they are not the same. So that's the variable length subnet masking. So if it is the case, you, for example, just will come to this one. For example, 192.168.1.30 /0/30. This has different subnet mask with regard to this one. So you can see this one. This is class C. So class C should have been subnet mask of 255, 255, 255, 0. But this is classless, so it is if it is classless, it's a different subnet mask than this one. So just will come what it means. So in general, our focus is usually on these two topics, on these three topics. So what is the meaning of speed of convergence? Speed of convergence means all the routers having the same information after some point of time. So to reach this kind of information, some of the routing protocols may get to that point earlier, others will reach to the same kind of, anyway, a common understanding about the network. So if it is, if you are using RIP2, so if RIP2, speed of convergence is low. If you are using EIGRP, the speed of convergence is fast. So that means routers will have the same kind of information at the faster speed for EIGRP and OSPF. What about scalability? When we say scalability, as the number of routers are increased, what will happen to the routing protocol? If it is RIP2, you can see that it cannot scale that much. So if it is EIGRP and OSPF, they can scale to the large network. So that's one advantage. Another one is the use of variable length subnet masking. All of them will use except the older ones. So the older ones does not use the use of variable length subnet masking. So what about the resource usage? The resource usage is usually OSPF will be high. They will use high resource. That means CPU, RAM. They will be utilized high. EIGRP will be medium, and the RIP version 2 will be low. And also for the implementation and maintenance, if something happens to your network, how do you manage? So if some kind of scenario happens, so usually RIP version 2 will be easier to maintain. So that can easily be maintained, but in the case of EIGRP or OSPF, they are not as such. So now you can see that we're going to discuss about what are the different metrics. Previously, we have said that there are different kinds of metrics to reach from the source to destination. For example, you can see here, here you can see multiple options. For example, to go from router 1 to router 3, you have multiple options. One of the paths is you can take this way, or you can take this way. So it depends now. You can see that the speed is different, the upper one and the lower one. And also what? Not only the speed, the distance is also different, or the number of hops. For example, to go from router 1 to router 3, in this case, there is a router between router 1 and router 3. If you select the upper path, that's called the hop count is 1. If you take from bottom, there is no hop count. There is no router in between R1 and R3. So it depends which kind of measurable value you are going to consider. Is it the speed of the cable? That's one case. Speed is one case. And another case is that it can be hop count, the number of routers between the source and the destination, so hop count. Another one is the combination. So you can see that there are different criteria to select. So if you are using RIP, it will just count the number of hops. That means if you take for example, if you go from some area to another area on car or on traffic, what are the criteria that you select to reach from the source to destination? One of them is the distance. If you take one path, it might be very far, but it might be what? It might not be jammed. There is no the traffic or the roads might be the side of the street might be big, so that it can accommodate multiple cars at the same time. But even if it is short, what if the number of traffics the road can accommodate are smaller? So in that case, it's not good to select those kinds of paths. So anyway, a measuring mechanism to select to reach from the source to destination, it depends on your metrics. If you are using RIP, it will count the number of routers. So hop counts means the number of routers between the source and the destination. Other one is OSPF will use what? Cumulative bandwidths. So for example, to go from router 1 to router 3 through router 2, you can say that here it is 56 kilobits per second. Here it is T1 around 3 point something megabits per second. So you are going to add these two and subdivide it, divided by 2. That's what we call it cumulative bandwidths. If you see the first one, that is very slow. If you see the second one, that's better than the first one. So you cannot base yourself either by the first one or by the second one. Just you are going to take cumulative. The third measurement, which is used by the EIGRP, it will use the bandwidth, and also it will use the delay, it will use the load, so reliability. Multiple metrics will be used by EIGRP. So what are the advantages of dynamic routing? We said that's simple. So whenever you have multiple routers, you are going to use dynamic routing. If you select something, a routing protocol which is independent of the network side, that means as the network size increases, it doesn't have any kind of effect on the network, then in that case you'll select dynamic routing. If you want the system to automatically adapt itself, you are going to select dynamic routing. But dynamic routing will have limitations. One of them is resource utilization. That's called what? Resource. CPU, RAM, bandwidth is highly utilized by the dynamic routing. If it is the static routing, there is no, it's much smaller than this one. The second one is what? The route depends on the current topology. So if you are going to select some specific path, you are not going to use usually the dynamic routing. You'll use, if you want the network to work on the current topology only, you are going to use static routing. Security, static routing, but those are the issues there. So let us discuss about that. So this is in general what? This is in general about the static routing and dynamic routing. So let us discuss some topics regarding the distance vector routing protocols. So distance vector routing protocols are what and what? There are two types of distance vector routing protocols. What did we say previously? We said two types, RIP v1, the RIP v2, and also EIGRP. These are the mainly two types of dynamic routing protocols. So now let us see from starting from the beginning. That's called from the cold start. Now you can see that this is router 1, this is router 2, this is router 3. So this is at the beginning of their routing table. So you can see that what? They have what? This is because the initial discovery of the network. So for example, we have said what? Router 1 is directly connected to two networks. So the first one is this one, the second one is this one. Router 2 is connected to two networks. With this one, which is shared with R1, and with this one, which is shared with R3. R3 is directly connected to two networks. The first one, which is shared with the R2, and the third one, which is only for itself. So you can see that these are the routing table information which are included on the first one. So you can see that router 1 have learned two networks. The first one is this one, the second one is this one. It will show you which interface that network it can be reached through. For example, you can see that the fast Ethernet 00 is directly connected with the 10.1.00. The serial 000 is connected with this network. So in general, these are the directly connected networks, which we do know them by C. So all the routers, router 2 will have two directly connected. So 10.300 through the serial 001 and 10.2.00 through the serial 00. So this is the initial information that is stored in the routing table. This is what we call the routing table, by the way. So this is the routing table. So now you can see that router 1 does not have any information about this network and this network. Router 1 only have two informations regarding. So if router 1, for example, wants to send some message to this network, it doesn't have a routing table, so you cannot send message. So in order to do that, you need to what? You need to discover networks. That's what we call routing. So now you can see here, what do you see here? Router 1 is sending router 1 is sending some information. So here the routers are exchanging updates to know about the remote routes. So anyway, you can see that update messaging is being sent by the networks. So what you see here now, router 1 previously it has only one, now it is learning 3 from router 2. So router 2 is providing an update to that direction and also to this direction also. Now router 1 has learned its network, and router 2 is exchanging an information with because it is exchanging information with both router 1 and router 3. Now you can see now router 2 is learning different networks. Previously router 2 do know only this network, but now it is learning two additional networks. The first one is what? This one from who? Router 1. And this one from who? This one from router 3. So router 2 is exchanging information with router 1 and with router 2. Just you'll keep on doing this thing, I think, until they become convergent. That's what we called previously convergence. Now you can see all of them have information regarding all the network. For example, now you can see that router 1 is saying, this is, we said routing table, router 1 is saying what? If I want to go to 10.4.00, I need to go through which network? I need to go 2 routers away. So this is the first router and this is the second router. So in order to reach this one, you need to go 2 hops. So that's what we call it hop count. And router 1 can reach this network through this interface. That means if router 1 wants to go to if it wants to go to this network, it should go through this path. That's what we call serial 00. So it should not go through this way. That's the backward side. Anyway, all of them will have this kind of information. Whenever they want to send a message, they do know that which way they are going to send their message. Let us say that router 1 wants to send a message to this network. Which way should it send it? It should send it through this exit interface. That's what we call it, exit interface. That means it should send it through this one. So if it passes through this one, router 2 will receive it. So what does router 2 will do? It will see it is stable. So when it sees it's stable, what does it do? It says, how can I reach this one? It says you should go this way. So it will send the message this way. Then the message will reach router 3. What does router 3 do? It will search for this IP. It can see that it is here. So which way should it send? It should send it this way. Well, how many hop counts does it have? 0. So that means it is reaching its destination. So this kind of information, we call it a routing table information. This is the very critical one. Whenever you have this same kind of information regarding the network, this is called what? Convergence. And also in this case, there is a concept which is called split horizon. Split horizon means what? An information which has been sent outside, it should not be sent back. That's what we could. Otherwise, coming and going or something like that will be a problem. So we have said what? That's convergence. What is convergence? So convergence means the time it takes for the router to share information and to calculate the best path and to update the routing information. We call them convergence. So I think we have already seen this one previously. So we say distance vector routing protocols, it will use what kind of information? So there are the different types of routing algorithms. There are different types of algorithms. We are not concerned about those kinds of algorithms. So there is some difference between RIP and RIP version 2. We said what? RIP is what? We said RIP is classful. What about the RIP version 2? It's classless. So from most perspective, we can say that RIP version 2, you can see it, the most of advantage of class 2. And the same with EIGRP and EIGRP. So this is Cisco proprietary. It's owned by Cisco. This one is a kind of used. Now we are not going to discuss about RIP version 2. Anyway, this is the command. Whenever you want to write a routing information, you should always remember this command. That's called only router. If it is RIP, you will say RIP. If it is OSPF, you will say OSPF. If it is EIGRP, you will say EIGRP. Similar. Just you'll say router. That's whenever you want to consider routing. So, and also you need to know that it is written in the global configuration mode. Anyway, in the configuration mode, the global configuration mode. So it should be written like that. So after this RIP command, you need to specify the networks. Usually, you need to specify the network with what kind of networks? Directly connected. So for example, this is the router 1. So these are the directly connected networks. So you are not expected to specify about the remote networks. Only you'll specify the directly connected networks. So which are the directly connected? These two. So we are going to use these two. But here you can see that there is no subnet mask. Why? Because we have said RIP is what? It is class full. If it is class full, you don't provide the subnet mask. By default, it is known. Because this is class C, so the subnet mask is going to be 255, 255, 255. Because it is class full. So sometimes we might use no auto summary. We will come to what is the purpose of auto summary. Auto summary means what? Summarizing multiple networks to a single value. That's what we call auto summary. For example, you can see the numbers here. All of them can be auto summarized to what? They can be auto summarized to 192.168.0.0. This is what we call summary, a kind of summary. Sometimes we might specify passive interface, but this one is very critical. So we need to propagate what? Default route. Don't forget this one, because if you want to use an internet on the router networks, you need to have what kind of information? You need to distribute where the internet exists. For example, you can see that internet exists only on the router 1. If router 3 wants to use an internet, if router 2 wants to use an internet, it should send its message to who? To router 1. So this kind of information need to be distributed to router 2 and router 3. Because router 1 is directly connected, it should be the one who is going to distribute. It should say that, hey, router 2 and router 3, if you want to use an internet, you can come and pass through me. How does the router 1 do this kind of issue? It will send with what kind of message? It will send a default route. So that's what we call default route is. Always it is configured on the router that is directly connected with the internet. So now you can see this is configured on router 1. So how do we write it? Just we'll say what? 0. The IP address is 000. The subnet mask is 000. And it will tell to other routers by sending this kind of information where what the IP of the internet is and which interface is going to be found. So you can see that this internet is found through this one. That is the IP address. The IP address is what? You can see it is .226. .226 means this IP address. And you can see that this is .1. That means what? That is this one. This interface is serial 0/0/1. So this interface. So here you are writing those two basic critical informations. So whoever wants to use an internet, this kind of information will be distributed to router 2 and to router 3. So whenever router 2 and router 3 want to send a message, they will send it to the router 1. That's what we call default information originate. And another important topic is what kind of information. So routing table entries, we call them entries. The information that you see, it's called an entry. This is one entry, that is one line. This is another entry, another line, another line. So every one of them, they are called what? Entries. We call them entries. So whenever you have a word C, what does it indicate? That is directly connected. If you see S asterisk, that means default route. So this is the default route. What is C? C is directly connected. What about R? R is what? R is RIP. So whenever you learn some information regarding this one, that's what we call it RIP. So this is what? Routing table entry. Now you can see that this routing table entry is for who? For router 1. So router 1 have how many directly connected networks? 3 directly connected. The default route, that is the internet, and the router 1, that's the internet, and another one is what? This network, the 172, I think a little bit the numbers are, there are no numbers that are specified in here, but that's the only problem we have. We can see that these are anyway directly connected networks. So these are directly connected networks for router 1. So what you see here, this is C, this C, this C, they are what? The directly connected ones. So you can see they are, for example, from directly connected networks, you can see that this one is what? Only by looking at the table, you can see that this one, for example, see 209.165, 200.232/30, it is found where? It is found on serial 00. That means this one. So the IP of this one is what? The 209.165, 232/30. So what about this one? This one is another one. That's this one. So that is the serial 000. That is what? That is 200 something, 209, 165, 200, 224. Anyway, and also this one. This one is this one, the first one. So whenever you have C, C means directly connected. What about R? R is which the router learns by the exchange of routing table information. So you can see, for example, this one, you can see this R found that is 209.165.230, that is the learned from the serial 000. So this one, it's going to be, you can see that there is administrative distance and values. Anyway, these networks are the networks that you learn them here. So this IP, this is 209.165.200.228. So these are the networks for this one. How does router 1 knows this information? By the R. R means what? RIP. That's routing information. So we have discussed about the. Now you can see that what the meaning of C. C is directly connected. What is the meaning of L? That is usually we call it what? So anyway, these are the routing informations. So whenever you see S, that's called static. Whenever you see D, that's EIGRP. Whenever you see O, that's OSPF. Whenever you see R, that's RIP. So now, for example, you are seeing here R. What does it stand for? It stands for with what? It stands for RIP. And also you have the administrative distance. You have the next hop IP address. You have the outgoing interface. So this is called the metrics, administrative distance and metrics. So all these are informations regarding selecting the best path. So these are the concepts that we will be discussing about these topics, and we'll come back with the next step. We'll come back with the configuration of different routing protocols.